So yesterday's was probably straightforward for you guys, and I'm gonna guess you'll probably feel like today's isn't bad either. It's going to be a completely different topic, but the kind of the point of these is we're sort of reviewing older things for the first handful of sections to show you how to use it for newer things towards the end of the chapter. So this is one that you've been taught before, but it most likely you haven't seen it since Algebra 1, and so because of that, it's going to take a little bit to remember. Inverses, relations, and functions. So our goal is going to be to take the inverse of a relation and to take the inverse of a function. So we should start with, if you guys even remember what the difference is between a relation and a function. Yeah, okay. So a relation is just a bunch of points that go together. There generally is something that relates the two pieces of data together. Like one might be age and height, things like that. There's some reason that these numbers are related together, so they just call it a relation. A function is a specific version of a relation where like there's only one answer for each input. Okay, so we're gonna work with this relation first. Kind of proud of myself. Look how nice and neat those numbers are.
Sure.
I know. I took my time. Let's go, Zach. Do you remember anything about inverse? I'm going to guess you have a semi-idea what inverse means.
Like the opposite?
Yeah.
Like inside out?
Yeah, most people probably in their mind kind of picture the inverse. Like most of you have probably seen the inverse of a picture before, where the colors are inverted.
Yeah.
That's probably the most common thing, not that that's common, but that's probably what you semi-picture.
I need the numbers.
They're right there.
Oh, I need the word.
The
bunch of points put together.
Yeah, a bunch of points put together. How were you that far behind, though? That was the first slide. You were too concerned with goldfish.
Because I take my time. And they're actually present.
Okay, so Zach said the inverse is like the opposite. We're going to invert the numbers. So inverting the numbers just means that you swap them. The x's and y's switch. So the inverse of that relation, I suppose I need a marker. Now I feel pressure that I have to write these nice. This wasn't good. I shouldn't have done that. So the top numbers would become 2, 4, 5, 6, 7. 0, 1, 2, 4, 8. All right, I'm kind of proud of myself. That actually came out all right. I'm a real adult now. I can write legible things.
Okay.
Although usually the real sign of adulthood is when nobody can read it. I can claim myself to be a doctor. My signature is very doctor-like.
Your signature?
Yes, you can't read it. You can make out the D and that's it.
I can't even write signature.
Are you done?
Yeah.
Okay. I'm assuming that went well. Yeah, either really good or really bad, I guess. Everybody else said it seemed to go quicker than normal too. There's way too many people gone for us to roll. Zach, why don't you choose somebody?
Katie, you got this.
Do you remember domain and range?
Yeah.
Okay, so what's the domain for the left-hand one?
0,
Yep,
1,
yep,
2, 4, 8.
yep. Domain is going to be 0, 1, 2, 4, 8. It's the x's. And then because the inverse means that you switch the x's and y's, that means the range of the second one is the same thing. Oh, it's so hard to make those little braces.
Oh, tell me about it.
Let's make me feel like a professional here. Oh, look at that.
I've never done one of these good. They look so
I would actually really good one.
Oh, now you put pressure on me. I screwed up that one a little bit.
Those look really good. I don't want to make you, that wasn't sarcastic.
It's very nice.
Uh-huh. It's really hard to do them like at normal speed. Yes. Okay, and then Katie, somebody's going to give me the range of the first set of numbers.
8
2, 4, 5, 6, 7.
I see. Took your time on that one. 2, 4, 5, 6, 7. So the range is traditionally the y's.
Oh, that was bad.
And then domain for the second set, because everything was reversed and inverted. Hi.
Hello.
He's here today. Deontay. That's an awful lot of writing on a little tiny fast. Anybody have any kind of questions on what's up there? My guess is you're probably pretty okay with that, and it's pretty straightforward. Okay? Then let's move on to functions. Oh, my bad. I forgot. I don't know if I want to graph them, though. We can graph them. That'll be fast.
Oh, no.
I feel like we were in on that conversation. Okay, for the first set, the original relation, this is going to be the 0.02. This is going to be 0.14, and so on. So I'll try to do these color-coded, I guess. That'll make it slightly easier to look at on the... it's just because all these numbers are positive, I only did the upper right-hand corner of a graph. Yeah, you can draw a full graph if you want, but all my numbers are positive, so I just did the upper right-hand corner. So 0, 2, 1, 4, 2, 5, 4, 6. Why is there so many people walking around today? What? Oh. Why do you keep talking to me and then like,
This is talking to me.
oh. Do you guys remember any of this from Algebra 1?
No.
Do you remember drawing inverse? No? Okay. Can anybody see, how should I phrase it? Can anybody see the pattern on how you would be able to draw an inverse even if you didn't have the set of numbers? Like say you were given the blue set of points to begin with. Would you be able to draw the inverse without even looking at like the numbers?
Probably not.
Okay? So if I draw a 45-degree angle, inverse graphs are mirror images around that 45-degree angle. So maybe even if I draw, let me kind of connect the points. Maybe that'll make it easier to see. But the blue lines, the blue information, and the green information, oh, that's a bad line, are mirror images around the 45-degree angle. And so if you guys are given a graph and asked to draw its inverse, you kind of have two ways to do it. One, you can draw that 45-degree angle and then just draw the mirror image. Or two, you could take the individual points, like you could say the point 0, 2, draw its inverse at 2, 0. You could do individual points and reverse them as well. If you want a tip, drawing inverse is really difficult like that. Since you guys have paper, it actually works super easy if you rotate your paper so that that dotted line is straight up and down. And then draw the inverse. It's usually much easier for most people. It's much easier for most people to draw left and right than it is at an angle. Does anybody want me to leave that info up there yet? Okay. Then now we'll work with equations. Right, this isn't much worse. I mean, it might look like it from up there. First thing is the notation for inverse is on the right-hand side. If you have f of x, that's like function notation, the inverse is going to be labeled as f negative 1 of x. And there's going to be two ways to do these. I also have a feeling basically everybody's going to pick the one method. Okay, first method is that you can't write it as f of x. You have to write it as y equals. Kata, did you pick? Oh, yeah. Okay. Grace, do you remember what we did when we were trying to find the inverse when it was just a bunch of points? How did we find the inverse on those first boxes? Flip what?
The numbers?
True, what do those numbers stand for?
Wait.
No.
X and Y.
Yes, okay. So to find the inverse, you flip the x's and y's. So the inverse of y equals 2x plus 1 is going to be x equals 2y plus 1. And then you re-solve it for y. So subtract 1. and then divide by 2. Well, with that, I don't want to write it like that.
Wouldn't it be a negative
If we were multiplying them, it'd be negative 1x. But I was just subtracting from both sides, so then it, I think that's what you meant, right? Yeah. And there's going to be lots of different ways we could write that, but I'm just going to leave it like that. Yeah.
Would you simplify it?
You can. I'm not worried if you do or not. But when you say simplify, do you mean like write it as 1/2 x minus 1/2?
Like, if there were numbers on, would there ever be numbers on, in place of x or 1? Like different numbers?
Oh, got you. Not when we're doing it for functions. So a function kind of stands for lots of numbers, and so we would just do it with an equation rather than individual numbers. When we're given a relation, then we're usually just given numbers only. I don't know, are you okay with this first method?
Yes.
I'm going to guess this first method is probably how everybody will do it. Because it's decently easy to remember. You just switch the letters backwards. The second method is absolutely different. So if I look at 2x plus 1, what's the first thing that's being done to the x? Like if I put a number in place of x, what's the first thing I do? Multiply by 2. And then the second thing I would do if I put a number in place of x would be to add 1. Well, the inverse is going to be the reverse steps. So the first step of the inverse is to subtract 1. The second step of the inverse would be to divide by 2. So the inverse is inverted operations, inverted order. And the way I would write subtract 1 and then divide by 2 is exactly what's written in the box up top. So those are the two ways to find an inverse. And obviously they're different. My guess is one of those two methods makes a lot more sense to you. Just pick the one you like. Like, I don't care how you guys find inverses. Yeah.
So you multiplied by 2 because of the 2x?
Yeah. Yeah, so if I put a number in place of x, the first thing that happens is multiply it by 2 and then add by 1. Put that away. Quit taking videos. Okay, move on. We're almost done. Like this section is relatively straightforward. Okay, if you guys can, I would like you to find the inverse on your own before we do anything graphing. See if you can find the inverse on your own. You pick whichever method you like. Hmm? It's not usually. I mean, if it's like super obvious, yes, but. So most of you should probably found it already. I'm gonna guess that a lot of you just wrote it as x minus 6 over 3. Nothing wrong with that. But because we're trying to graph it, I wanted to write it like slope-intercept. And they're both correct. Like, you don't have to write it both ways. So if I want to write it as slope-intercept, what I do is I just divide each number by 3 instead. So I would divide 1x by 3, and that's 1/3 x. And then I would divide -6 by 3, which was -2. And then if I go to graph them, 3x plus 6 crosses at x equals 6 on the y-axis, and then has a slope of 3. So up 3 over 1, or down 3 back 1. I don't know if I can drawing straight lines on this is hard, but we'll go for it. Yep.
Wait, how did you get 1/3?
So the x right there doesn't have a number on it. So the number is a 1. So this is like 1x minus 6. So if I do the divided by 3 on each one separately, that's where the 1/3 came from.
I tried just dividing the 6 by 3.
Oh, gotcha. It would have to be on both.
Okay.
Yep.
But you can like separate.
Yep. So that green line is 3x plus 6, which is the original function. And then if I want to find the inverse, I know it's going to hit at 6, 0 because the other one hit at 0, 6. But the inverse is 1/3 x minus 2, so minus 2. And then a slope of 1/3 would be up 1, right 3. Up 1, right 3, up 1, right 3. Did I do the graphing too fast?
No. Yeah. No. It's just, it doesn't look the same on the
Oh, yeah, definitely on paper it's harder. If you don't remember how to do slope-intercept very good, you could, because we know they're straight lines, you could just put 2 points on there and make that your line. So, like the inverse, when we found it, we could just make like a really tiny table, and we could put 1, 0, and 1 in place of x, and then find the y values. So if I put 0 in place of x, I'd have 0 minus 6, which is -6, divided by 3, which would be -2. If I put 1 in place of x, 1 minus 6 is -5, divided by 3, -1 2/3. So I could just kind of make a little table, which that may or may not be okay.
Wait, how did you graph the 7?
I took that equation.
Did you do the other equation?
I'd used those 2 equations to graph. So if you guys remember, the second number that's by itself is the y-intercept. So that's where it starts from. The number that's on the x is a slope. So a slope of 3 over 1 would be up 3 to the right 1. Over here, 1/3 x minus 2. The -2 is the y-intercept. And then the slope is 1/3, so I went up 1 to the right 3. Yeah.
So basically, all like you're taking that problem, and then all the work you're doing is just defining the inverse, and then you graph it.
On this particular one, yeah. You're not going to have to do that on every question.
But could you graph the x minus 6 over divided by 3? Could you graph that one too?
Yes, if you graphed it like from here, you'd probably want to make like a little table to graph it, because it's not really written for graphing. Or just remember what an inverse looks like. Like the first graph that we did, this is the point 0, 6. And this was the point, because we went up 3 over 1. This is the point 1, 9. The inverse would have the point 6, 0. and 9-1.
Oh,
You could graph it that way too.
okay. Okay.
There's lots of different ways you could graph it. And I think that was it.
That's kind of a lot.
It's not a lot, it's been a long time since you guys did it probably. Yeah.
When will our test be?
Graded?
No, like, for this one?
Oh, when is going to be the test? It's a good question.